Hi everybody, it's been a few weeks now since I did my last video, and since then I've invested in a little lapel microphone. I'm just testing out today and see how that works. I had a few comments about the sound levels, and one person suggested that maybe I should try a lapel microphone, so I'm giving it a go. Anyway, today I'm going to have a little break from the DC load project we've been working on, but I will come back to that with some additions to that particular project shortly. But I thought today I'm going to indulge myself a little bit and go back in history to 1980, when I got my first computer, which was the Sinclair ZX80. And that, if anybody can remember it, was launched by Sinclair to the home market, to the hobbyist, for around about £100 back in 1980. Now, the one I was using then I no longer have. The nearest thing I've got to it is effectively a cardboard cutout, so that's what the ZX80 looked like. But what we're going to do today is try and build a copy of this, or at least a clone of the ZX80, and to do that, I'm going to use a printed circuit board which has been designed and made by Timemouth Software. That's Dave Curran of Timemouth Software. Has put a lot of effort and work into producing a very good PCB, this particular printed circuit board, which is in the same format as the ZX81. And in that respect, it means that when we build this, we can actually mount this in an old ZX81 case and then try and make it look like a ZX80. So that's what I propose to do today. Now, the first thing I'm going to do is have a look at some of the basics between the original ZX80, and then discuss some of the changes that we're going to make as a result of using this PCB from Timemouth Software. It's actually some improvements from the original ZX80 circuit, but at least maintaining the functionality of the original ZX80. So let's have a look at some of the detail behind this project today before we delve into making, or at least having a go at making, a clone of the ZX80. Here we see the basic arrangement of the original Sinclair ZX80. Just quickly go through that. The central processing chip was a Z80 IC, and the memory, they used only a 1K memory at the time, and that was made up of using two ICs, the 2114 IC, and that was simply addressed by using address lines A0 to A9 from the main processor and the data. The reset pin of the processor there was reset at switch on by a simple RC network there, so at the point of switch on, the reset pin there is low, so resets the IC, but then very quickly the capacitor charges up and is taken out of circuit. So it's just resetting there at switch on. The ROM circuit there that's got the operating system in and the basic language in there, that was a 4K ROM on the original ZX80, and that was addressed using lines A0 to A12. The actual A12 address was used as a second chip select on the original ZX80 because the ROM that they used was capable of being programmed in such a way where you could have two ROMs selectable by A12, but in the case of the ZX80 they just used one ROM, which was the 4K ROM. The chip enable pin was fed via the main processor through some logic circuit there, so that takes that pin there low to select this particular ROM. The output was then fed through logic circuitry. They're supplying sync and video signal into an RF modulator, feeding the signal then out to a RF socket there, which went out then to a normal television aerial socket, and it went on at UHF band on the TV. So that was the original circuit layout of the ZX80. Here we now see the changes that we'll be making on the ZX80 clone, which improve both the memory capacity and the ability to switch between ZX80 ROM and a ZX81 ROM image. So first of all, we have a look here. We can see that the RAM memory now, the SRAM, has been increased from 1K to 16K. We're actually going to be using a 62256 IC, which is in fact a 32K SRAM, but we're only going to be using 16K of that 32K, and hence the reason why we've taken the address line A14 up to plus 5 volts. So we're only using address lines A0 to A13 to address the first 16K of the 32K memory of that chip. Now previously we only had 1K there, and the address lines we used was A0 to A9, so we've added A10 to A13 address lines now going to the memory chip. So that's the first change. The second change is that, remember, the reset pin on the CPU just had a switch on reset with the simple RC network there. We've now added a little push button, tactile push button to ground, which gives us the ability to do a hard reset by simply pressing the push button. The next thing we've done is we've altered the ROM, which holds both the basic interpreter and the operating system for the ZX80. Originally that was a 4K ROM. We've now changed it in this particular application here to a 16K EEPROM, and I'll be using the 27C128 IC, which is a electrically alterable programmable ROM. Now this particular chip, although it's got 16K, we're going to split it into two halves, so two 8K chunks. In the first 8K of the memory of that chip, we're going to store 4K of ZX80 ROM image, and in the second 8K of that 16K memory, we're going to store the ZX81 ROM image, which is 8K. And to switch between the two, we're going to use address line A13. If we take A13 low, it only looks at the first 8K of that memory, which is addressed by lines A0 to A12. If we take A13 high, then it looks at the second 8K of that EEPROM memory, and in that case we're going to be looking at the ZX80 ROM image of that EEPROM. So this gives us the ability to store both images on one IC, and simply by switching A13 high or low we can select either of the two ROM images. Now, as I'll show you shortly, we can actually have ICs there that have got more memory in, so we could have the 27C256 or the 512, and I'll show you the switching or selecting arrangement of that shortly. The next change we've made is that we've allowed the chip select pin for the EEPROM to be available on the edge connector. That's actually what happens on the ZX81. It was not on the ZX80, so we've given that feature to the ZX80 here, so it complies with the ZX81, and in order to do that we've added a 680 ohm resistor between the chip select pin of the EEPROM and the logic circuitry of the rest of the board. So that just gives some isolation there if we take the ROM select pin low from the edge connector, from an external source. And finally, we've disposed of the RF modulator unit and replaced it with a video amp and pulse shaping circuitry to give us a clean video signal at the output there. So that is then going to the video input of our monitor, and what I'll be doing is using on the TV there, I'll be using the SCART output with a little adapter to select the video input for the TV. So there we have the changes that will be made on our clone of the ZX80, keeping the original ZX80 by allowing it to operate from that ROM, but giving us also the ability to switch to a ZX81 ROM if we wish. And of course we've got the extra memory now as well. Here we have a table just illustrating how we select the ROM images depending on which EEPROM we're using. On our project today we're using the 16K ROM, the 27C128. So to select either the first or the second 8K part of that 16K ROM, these are the link connections that we use for A13, 14 and 15. Now on the 27C128, what would be pins A14 and A15 on the larger memory chips are program enable and VPP for programming, so they're not A14 or 15, and in order to ensure that they don't affect things, we have to have both of those connections going high. So we're only interested in the logic level that's here on A13, as I illustrated earlier. But if you were to put a 32K ROM in, the 27C256, you then have the possibility of 8K in 4 images. So you've got 4 images there of 8K. And this time A14 is available on the 27C256 chip, and therefore the combinations of the links are as follows. A13 low low gives us the first 8K, high low gives us the second 8K, low high the third, and high high the fourth. And again here you'll see A15 doesn't exist on the 32K ROM, and therefore all of these need to be high because that particular pin on that ROM is the VPP pin, the programming pin. So that's just 2 examples of how we can select the different ROM images in 2 ROM EEPROM memory chips there. You could actually have a 27C512, which is a 64K memory, which would be double this, and in that instance then the A15 pin there comes into play, so they'll be going low and high to select the additional 4 8K images. Well, we'll have a look at the printed circuit board and the components for this particular project today. Here we see the printed circuit board, which has been designed and manufactured by Dave Curran of Tynemouth Software, and it goes under the name Minstrel, this board. The form factor of it is identical to the ZX81, but this is in fact going to be a clone of the ZX80. The printed circuit board is double-sided, very well made, plated through holes, and as I say, is available from Tynemouth Software, and I'll give you the link below. The silk screen on the front side of the PCB is very nicely laid out with all the component values marked and the IC types marked as well. So it makes it very, very easy to assemble without having to refer back to the circuit diagram all the time. The board has some link pin connections. There's a group there which is associated with the EEPROM, and that allows us to select different images of ROM if you put a larger EEPROM in there. And also on this side here you've got another link there that allows you to change the video output from invert to normal. So I'll show you that later on. He's also added, as you see there, the little tactile reset button, which was not on the original ZX80, So it's a nice little addition there. And you'll also notice that there is no RF modulator, as I mentioned earlier, on this board, and the video output is simply going out to a phono socket, which will be mounted there, and the IC in that corner of the printed circuit board is what produces the nice clean video output with the sync pulse. The keypad for this project, I'm going to use this particular keypad here, which is actually the ZX81 keypad arrangement with the flexible connection there. If you've got the old ZX81, you may be able to reclaim the keyboard that's already in the box, but I found that if it's quite old, the plastic flexible cable here tends to crack on the original ZX81, so you may not be able to use it, but you may be able to reuse the old one. If not, this particular version you can purchase from RWAP software, and again I'll give you the link for that. This is being produced by Rich of RWAP software. A nice little keypad there that you can use on this project. And because we're going to build the ZX80, then I've got this overlay, this keyboard overlay here, which also came from Time Mouth software, and when we finish the project, that will simply stick on top of the ZX80 keypad there. Here we see the old ZX81. This is actually a faulty one which I got off eBay. If you buy the faulty ones off eBay, you can get them relatively cheap for around about £10. So this is a faulty ZX81, and the main reason I purchased this was to use the case. But we may also be able to reclaim some of the components to use in this project as well, which will reduce the overall cost. So what we're going to do is disassemble this and take out the original board. I've already taken off the rubber feet that were stuck on the base of this, so I'll just unscrew the bottom and then we'll have a look inside. Right, well, I've now removed unscrewed all the screws. There's 5 screws to remove on this. 1, 2, 3, 4, 5, and then the bottom base comes off. So that now exposes the ZX81 PCB, which I'll now remove. There's just 2 screws to remove the PCB, one there and the other one just there. So if I just remove those 2 screws, then we can take out the whole unit. Right, you can already see that the strip connector to the keyboard is already cracked and broken. I'll just show you that. This is what tends to happen, is they become very brittle over time, and then they tend to crack and break. So in this particular case we probably can't use the keyboard, so I'll take that off the case. It's simply stuck onto the case at the front, so I'll take that off and I'll use the new one that I purchased. We'll just have a quick look at the ZX81 PCB. I'll just point out some of the items that we can reuse on our project. We can reuse the main processor chip, which is the Z80 processor, and also you see these connector sockets there for the keyboard. We can reuse those as well if we unsolder them, and maybe you could even use the voltage regulator, or I think in my case I might just put a new one on, but you could reuse the one there. And I'm going to also probably reuse the heatsink, which is on this ZX81 PCB at the moment. So there are just a few components that we can reclaim and use in our project today. There we see the 2 PCBs side by side, and you can clearly see that Dave Curran from Time Mouth Software has produced this PCB to exactly the same format as the ZX81, so it'll just slip into the case with no problem whatsoever. He's even gone on this version of the board to mark in the fixing screw holes. You'll see there with the white circles around them. those are the two fixing holes for fixing it to the ZX81 case. To show you one or two of the other components going on the PCB, I've decided to put IC sockets on the board. Here we have the 40-pin socket for the main processor, the ZX80, and the two sockets there, the 28-pin sockets there, are going to be for the RAM and the EEPROM. The other ICs, you can either solder them straight onto the PCB. In my particular case today, I'm also going to use IC sockets for them as well. Just makes it easier to replace any if we have any issues. In place of the original 3.5mm audio jack, which was used on the original ZX80 for the power input, I'm using here a 2.1mm DC jack, which is a standard DC jack you'll see these days on equipment. And the output for the ear and the microphone, this is going to the cassette for save and download of the programs from your cassette. There we're using some small printed circuit board stereo 3.5mm jack sockets, and I'll give you details of this on the parts list and also where you can purchase them from. There's the phono socket that we're going to use for the video output, since we're no longer now going to use the RF modulator. So again, I'll give you the details of that on the parts list. The inline strip here, you see, I'll simply cut the link pins off of that to go onto the board, both for the selecting the EEPROM and also for selecting the video output, either normal or inverted video. So here we now see all of the components mounted onto the PCB. As I mentioned, in my case I've mounted all of the ICs in sockets so we can remove them if we have any issues with faults. It just makes it a little bit easier, but if you want to save on cost, you can solder all of these logic ICs here directly onto the board, but I would strongly recommend that the processor, the RAM memory and the EEPROM there, that you use sockets for those three. There you see the sockets there for the keypad, so that'll take the flexi cable from the keypad. There we have the links that will allow us to select the appropriate EEPROM image. In my particular case today, I've decided to use a 27C128 EEPROM, which gives me the ability to store in that images of both the ZX80 and the ZX81 ROM, and we can simply select either by the appropriate links there. There we have the link for the invert and non-invert or normal video output. There we have the 6.5 megahertz crystal. I couldn't get hold of a low profile version, but in any event this still fits in the case okay, so it's not an issue. The 6.5 megahertz crystals seem to be difficult to get hold of for some reason, so if you find you have some difficulty, then an alternative there would be to use a 6.5536 megahertz crystal, which are more readily available, strangely. But I'll give you details of all the components on the parts list. This is the little EEPROM programmer that I use to program the images onto the EEPROM for this project. It's quite a useful little device. I purchased this off eBay. I think they cost around about £40, but you can use it for so many projects, so it's certainly well worth getting. This one is called the Mini Pro EEPROM programmer, so if you search for that on eBay you'll find probably lots of suppliers offering this particular unit. Now, just a word of warning on soldering on this PCB. Make sure that when you're doing it you're using a small tipped iron that's clean, and it might be also useful just to add a little bit of flux from a flux pen onto the connections, and just make sure you don't have any dry joints. If you get any dry joints, then you may find you've got some issues, so just be careful when you do the soldering. You may also need a bench magnifier because they're quite small and you don't want the solder to leak across to the other tracks or the other connections. So just take some care and time when doing the soldering on the PCB and you'll be fine. Well, what I'm going to do with the case, just so it looks more like the original ZX80, is I'm going to spray this white. And for that I'm going to use some white gloss radiator paint, which I found works quite well. But when you do spray these, make sure you're in a well ventilated space because of the fumes coming off the spray. Now I did mention that the particular keypad on this second-hand ZX81 that I purchased is faulty. As I say, it was cracked, so I'm going to peel this off. It's just simply stuck onto the case. I'm going to peel it off, and then I'm going to spray the case white, and I'm also going to take the ZX81 logo there, the red one. I'm going to cut that down and then just sand it so it's smooth and level with the rest of the board. I'm going to leave the Sinclair black logo there on still at the top. So let's do that, and I'll come back and show you my efforts of taking off the keypad and spraying the case white. Right, well here we have the case now. I've sprayed it white. I did peel off the keypad and then cleaned it with some isopropyl alcohol just to get any stickiness off that. But what I also did is I covered the keypad area with a bit of paper. So that when I sprayed it, I didn't spray the white onto this area here, because that's where we're going to stick the keypad. So that's the case sprayed. It took a little while to dry, so just be a little bit patient there when you do yours. And of course the bottom of the case, I did exactly the same. That was sprayed as well with the same white radiator paint. So the next thing I think we'll do is we'll fit the keypad there onto the case. That'll just simply stick on there with the flexi cable then coming through at the back. It's quite simple to put the keypad onto the case. There's a peel off strip on the back which we can just simply peel away, and then we can feed the flexi cable through the holes there and then stick the keyboard down onto the case. Here we now have the keypad firmly stuck down on the case and just pressed it down, and as you can see the flexi connector is simply just coming through at the back, and that'll go onto the PCB. What we will do next is we're going to do an overlay on this so it looks like the ZX80. This particular keypad, as I mentioned, is actually a replacement for the ZX81. So what we're going to do is put the ZX80 overlay stuck on top of that so it looks like the original. Here we now have the overlay firmly stuck onto the keypad, so as you can see there, that now looks like an original ZX80. So the next thing we'll do is we'll mount the printed circuit board into the case. When connecting the membrane keypad, the flexi cable here, the first one to connect is going to be the 5-way cable. We put that in there, and then we'll do the 8-way one in the next. Both cables are now plugged in. Just take a little bit of care when plugging them in because they can be a little bit delicate, but make sure that they're firmly plugged into the sockets there. So once they're connected, we can then turn the board down and mount it onto the PCB. But before we do that, we have to make sure that the jumper links for the ROM are set correctly, and also you need to decide whether you want the normal or inverted video coming out. So I'll just show you that. As I'll be using the ZX80 ROM initially on this project, the little connectors here are going to be set in that position. So A15 and A14 are set high and A13 is set low, and that will select the ZX80 ROM. The invert and normal connector there, I've put that in the invert position. I found that on some modern TVs that that shows the clearer image, and you'll see that when I demonstrate it. The next thing we'll do now is we'll turn the PCB round and mount it on the fixings in the case. It should line up with the there we have the PCB now firmly mounted in the case with the two fixing screws fitted. I found it just a little bit tight on the pedestal underneath there, so just take some care when you're positioning the board that it fits in correctly. Right, well, I've now also just put the base on temporary, just with a couple of screws in, just so we can test it before we finalise the project. Now, one final little touch would be to have the original ZX80 logo on the case there, and so what I've done is I've made some transfers on some clear acetate, which is self-adhesive on the reverse side, and I've printed 4 slightly different size logos there, and I think looking at them, I think the 4th one there looks about the right size. So what I will do is I'll just cut that one out, and then I'll peel off the backing and then stick that on the case. There we have now the logo stuck on top of the case there. So it's looking more or less like the original ZX80 now, which I think looks quite nice. Right, well, here we now have the ZX80 connected up to the TV via the SCART connector at the back there. What I'm actually using is one of these SCART to phono adapters, which you usually get with computer game consoles, and using the yellow phono socket there. So we have it connected at the moment. It's on the normal mode, so you've got widescreen with the characters there. That's the cursor at the moment, so let me just type in one of the program words. So if I type in print, so you can see there we've got the word print there. I think what I'm finding is that if you have it set to the normal mode where you've got white screen and black text, it's a bit too bright. So I think what I will do is I will just alter the little jumper lead on the PCB inside the unit to the invert mode, and we'll just see whether that improves things. Right, well, now I have the link on the ZX80 PCB switched on to the invert mode, so you see we now have a black screen and white text there. So let me just type in one of the keywords. Again, I'll type in print, and I think you'll agree that that's coming up much clearer on this monitor than when we had a white background. So let me just clear that. And I'll just type in a small program. Well, I've just typed in a few lines of code there in a for loop just to print out Scullcom 12 times on the screen. So let me just run that. That seems to run quite well, so that's working okay. So I'm quite happy with the project there. It's working fine. A little bit difficult with the reflection on the TV screen here, so your image might not be as clear as I can see it at the moment. Well, I hope you've enjoyed this little project today in building this clone of the Sinclair ZX80. If anybody is interested in building this, then I'll give you details, a link down below for Timemouth software where you can order the printed circuit board for this. The board itself costs £20, but he also provides the overlays as well for the keyboard, and you'll see that if you go to his website within the offering that he's making for this. I think the overlays, you get both a ZX80 and 81 overlay for £5. Now, when you do order this from Time Out Software, although you do get a layout diagram of the components on the PCB, sadly there is no schematic diagram. So what I've done for the project today is I took the original ZX80 schematic and made changes to reflect what Dave Curran did at Time Out Software. So I'll make this schematic diagram available as well as a download, and in addition to that I've also redrawn the layout of the board, and I've put the reference numbers on there so that the components match the schematic diagram that I've put together as well. So those will be provided as a download. Now, the logo that I've put on the project there, I'll also make that available as a download as well, so you can download the images to print your own logo and put them onto a self-adhesive acetate sheet and then stick it on the final case. And as I say, the overlays on the keyboard, you also get the ZX81 overlay as well, so that means that if we switch it over to the ZX80 ROM, then we can just lay that on top and we know exactly what keys are doing what. Now, before I finalise this project and screw the case together and stick the feet on the back, I did manage to also find a supplier for the replacement rubber feet to go on there, and I'll give you details of that as well. But before I actually put the rubber feet on and screw it all finally together, I thought I'd make a couple of little modifications to it. It's very difficult once you've got the unit all assembled and screwed together and the feet stuck on to get access to the well, it's impossible to get access to the links to change the ROM image and to change the video output from normal to inverted or negative image output. So I think what I'll do is drill a couple of holes on the side there at the back and put two switches there, two little switches, one for the ROM so we can switch the ROM from the ZX80 image to the ZX81, and another switch where we can switch the video from normal to the inverted video. So that'll just make it a little bit easier when you're using it from a practical point of view. But having said that, the unit works very, very well. I'm quite pleased with it. So if you're interested in having a go yourself, as I say, all the downloads will be down below. I'll also put you the ROM image as well, which you can download for programming your own EEPROM. If you found this little project of interest, please give me a thumbs up and subscribe, and I'll see you all again soon next time. Bye for now.